So, to this point, we have talked about the atom, and we've talked about protons, we've talked about neutrons, and we've talked about electrons. And now we are going to talk about the electrons that are most interesting in chemistry, or in my humble opinion, are the most interesting in chemistry. And these are electrons that are found in the valence shell. So, the valence shell is just that outermost shell of an atom. And so while we know that the electrons don't kind of orbit an nucleus like the sun, I just said that in the previous screencast, sometimes it is helpful to look at that model. And so when we talk about the different shells, so this is a nucleus here, it's got plus 14, it's silicon's nucleus. And we can see there's one shell here, and there's another shell here. And then this is this outermost shell where these four electrons here are darker than the shells here, than the electrons in these shells. That outermost shell is called the valence shell. And the reason that's interesting is because the electrons in that shell, called valence electrons, play a role in bonding. And that's what we're interested in chemistry. So let's put some definitions to this. Valence electrons are the outermost electrons that play a role in bonding. And so what happens is with electrons, right? And we said electrons were in orbitals. And so the orbital for the carbon that holds one of these electrons in blue and the orbital for the hydrogen that holds another electron in the red come together and overlap. And when these orbitals overlap, these electrons form a bond. And that to us as bonding is really interesting because we get new chemicals that way. So, when you talk about valence electrons, maybe the burning question in your heart is, hey, Dr. Pierce, what about those electrons in those other shells? Do they have a special name? Well, they're called core electrons. And so we say, hey, look, those are the electrons located in the inner shells, right? So silicon, for example, if you look at the periodic table, you'll see that silicon has 14 electrons because it has 14 protons, right? And so since there's no charge, we know that the number of electrons has to equal the number of protons. And so we can say, all right, hey, look, I see that there are 4 electrons in that outer shell. And so that means silicon has 4 valence electrons. And so to figure out our number of core electrons, we just take the total number and subtract of electrons and subtract the 4. And that gives us 10 core electrons. So without having to look at kind of this diagram of every element, there is another way to know how many valence electrons each element has. And that is to use the periodic table. Now, we're going to talk about the periodic table in another screencast, but I want you to look at these kind of two very abbreviated versions of the periodic table. And I want you to look here. The periodic table arranges atoms in such a way that we can gain useful information from it. And one of the things that we can gain is the number of valence electrons definitely in the main group elements. Now, we're not going to mess with the transition metal valence electrons, but we're going to look at the main groups. And so that group number indicates the number of valence electrons. So these in group 1 have 1 valence electron. These in group 2 have 2 valence electrons. Now we're going to skip over all the stuff here in the middle and come to 13. Now in some older periodic tables, you'll see this is like 3A sometimes, or sometimes, I said 3A really confidently. Actually, I think it's 3B. So you'll see these as Roman numerals. However, what we're finding is that most people have switched to 13, 14, 15, 16. And so what we find is that in group 13, there are 3 valence electrons, 14, there are 4, 15, 5, 16, 6, 17, 7, and 18, 8. And so what I do is I just cover up the 1 here, and then it'll tell you how many valence electrons these atoms in each group have. And that helps us figure out and predict bonding. Now, the periods indicate the energy level for the atoms in the main group element. And we're not going to do as much in this class with the energy level. It's just kind of nice to know that particular energy level. Now, I want to draw your attention over here to group 18. These are called the noble gases. And that's spelled noble, like the nobles of kind of England, right? And though the noble gases were actually named after kind of like the noble class. I want you to notice that these noble gases have 8 valence electrons around them, and helium here only has 2. Now, these are famously unreactive. They do not react at all. They were some of the later elements to be discovered, kind of in the great race to discover elements, because they didn't react with anything. And so they, very similar to the nobles that of England that didn't interact with the peasants, that's why these are called noble gases, is because they don't interact with any of the other elements, unless now, of course, we know there's some reactivity with really extreme conditions. So this leads us to the octet rule. And basically, because those elements in the noble gas, kind of the noble gases there, are so stable, what we find is that atoms of elements in other groups tend to be more reactive because they're trying to achieve having 8 electrons in their outermost shell. And so that leads us to the octet rule, which states that elements usually react to get 8 valence electrons, right, in their outermost shell. Now, there's 2 ways they can do this. They can give up an electron or they can gain an electron. And so I know this is pretty pixelated, but I wanted us to look at this. This is sodium and this is fluorine. And what you'll see here is fluorine in its outermost shell has 7. And so sodium in its outermost shell only has 1. So sodium will give 1 electron to the fluorine. And when it does that, fluorine will now have 8. And then sodium in its outermost shell is empty until we pop back here. And now its outermost shell that has electrons in it have 8. Okay, and so there's some exceptions to this. Really good examples like helium only likes 2, hydrogen only likes 2, but for us, most things are looking for 8. So as I mentioned before, to get 8 electrons in the outer shell, elements are either going to give away or take an electron. And we can also say they lose or gain. When they do this, they become ions. So one of the things you can see is that if an atom loses 1 or more electron, it's called a cation, and it becomes positive. So cations occur when atoms have lost 1 or more electron to become positive. And these are metals, right? And then anions gain electrons to become negative, right? And these are nonmetals. Now, I want you to look at the pattern. This matches, a lot of this matches the valence electrons. When we look here, everything in group A is going to form a +1. Okay, when it forms an ion. Everything in group 2A that's shown here is going to form a +2. Okay. We're going to deal with the transition metals later. Aluminum forms a +3. Okay. We're not going to deal with anything in 4, but look over here, all the way to the noble gases. We're going to ignore those. But notice everything in 7A, it's got 7 valence electrons. It wants to gain an electron to get to 8. And so now its charge is -1. Here in 6A, it's -2. And here in 3A, it is -3. And I second guessed myself on the previous slide. Those older periodic tables do use A instead of B. Okay. So these are our ions, right? And these ions form to achieve that octet. Now, I love visuals, so I have 2 visuals of ions forming for you. One of those is chlorine ion forming. And so when we look at this visual, what we see here is we have 17 protons and 17 electrons. And the chlorine atom gets 1 extra electron, and now it's got 17 protons. Protons don't change, right? Protons are going to tell us that's chlorine. They're not going to change. And now that we have 1 more electron, that's where we get that negative charge. So now it's an anion of chlorine. And even go to a step, yeah, it's an anion of chlorine. Now, let's look at the next, let's look at cations next. So when we come over here and look at cations, we're looking at sodium. When we look at sodium, sodium has given up an electron. It's still got 11 protons. Protons are not going to change in this. But one of the things you can see here is because it's given up an electron, now we have 10 electrons. So we've lost an electron in this process. Because we have 1 more proton than the electrons, now we have a +1 charge. Okay? And so that's why these ions carry charges, is because they have different numbers of electrons than protons. So I'd like to do an example like you would run into in your homework or on an exam. So how many protons and electrons are present in a single atom of the following? So we're going to look at oxygen, right? And this is where it's really important to look at the periodic table. This is where you're going to start. So I go to my friendly periodic table, and when you look at the periodic table, you want to look at the atomic number, which is that whole number, because that's going to tell you the number of protons. So when I go and look at my periodic table for oxygen, I see that it has an atomic number of 8. So that tells me it has 8 protons. Now, what this -2 tells me is that, look, this oxygen is an ion, and it has 2 more electrons than protons. That's what it tells me. So that means I have to add 2 to 8 to get my correct number of electrons. There's 10 electrons. Okay. You can always take the difference between these two and make sure that it gives you the -2. I think sometimes what throws students off is that electrons are negative. And so whenever you add an electron, you get a more negative number. Okay. So let's look at magnesium. Same thing. We go to the periodic table for magnesium. We look at the atomic number. The atomic number is 12, and so that means we've got 12 protons. Right? And then what this 2 here means is we have 2 fewer electrons than protons. Right? Which means we've got 10 electrons. And when you put those together, that gives you a +2. And then if you want to pause and try to do iron on your own, I would encourage you to do that. But I'm going to go ahead and work through iron 3+. So we go to our periodic table. We say, oh, look, that's got 26 protons. And now we have a charge of +3. So that means we've lost 3 electrons. And so we're going to have 23 electrons. We'll continue to do more examples in class. If If you have any questions, as always, please feel free to stop by my office and I would be happy to help.